Hey there, everybody. Welcome back. This is 15.6 in Calculus 3. We're talking about flux. In the last video, we saw flux is the surface integral or the double integral of f dotted with n, where f is the flow through a surface and n being the descriptor of the surface. And so we can think of flux as the volume of fluid that passes through the surface in 1 unit of time. And this equation makes kind of sense. If we think about it in that sense, the bigger surface area, the greater volume. So if S gets bigger, the volume goes up. If the flow is faster, remember we're using F equals rho V for like a water in a pipe. So if the flow is faster, the force is higher, and then the entire thing goes up. And that makes sense. More volume should come out if it's flat, faster flow. And if it's pointed directly in the direction of the pipe, it should be faster. If we're looking at flow coming, like how much water is going that way, like just barely out of the end of the pipe, usually nothing is going that way, to be honest. If the pipe is unobstructed, water flows straight and doesn't spread to the side until maybe it gets a little bit further out and wind and stuff like that affect it. But if there is something that's kind of like impeding the flow, like if you hold your thumb over the hose, the flow through your thumb is obviously going to be 0. So that's stopping the flow. F is not in the direction of N anymore, is where I was going with that. So example is looking through the end of an unobstructed pipe, like I was saying. If we look through the side of the pipe or through your thumb, if your thumb is covering it, there's no flow. And so F dot N gets lower. So this kind of like makes sense. And we've got, we can see that mathematically through the side of the pipe. F dot N, the dot product is the magnitude of each one times the cosine of theta between them. But the flow is going one way and N is perpendicular to it. So, or orthogonal to it, which means it's 0. So if S is given by R, we vectorize or parameterize it with UV, then our F dot N ds switches over. We talked about N being RU cross RV divided by its magnitude. But then we have, when we do the Jacobian for doing this switch over from dx dy over to du dv, we got RU cross RV for the Jacobian du dv. And so they kind of cancel out. Look at that. Boom, boom. And so F is dotted with the cross product of RU and RV. The partial derivative of R with respect to U and the partial derivative of R with respect to V. That's it. We're doing examples in the next video. Peace.